Can someone remind me? You've been given two strategies to solve simultaneous equations. What was the first one? Graphing it. What was the second one? Substitution. So substitution was when one of them had x by itself or y by itself. This last one, solving by elimination, is the final method. It's called this because you eliminate one of the variables, x or y. What situation do you do this in? It's when both equations are in general form. So these are your steps. Much like last week, the steps seem a little confusing as you go through them because you have no context. But when you see how the steps work, it makes sense after. So the steps for solving by elimination: make sure both equations are in general form. Choose one of the variables to look at. So you have a choice. Choose x or y to look at. Step 3, look at the coefficient. Does anyone know what the coefficient is? If I wrote these two numbers, 2x, which is the coefficient in 2x? 2 is the coefficient, so you do have an idea. Well done. Step 4, decide on an operation to apply to all terms of one or both equations, which will make the coefficients equal in size, opposite in sign. That's the hardest step of this and the one that you'll need clarification on. Step 5, add equations vertically to eliminate the chosen variable. 6, solve for the remaining variable. And step 7, substitute what you found in step 6 into either of the original equations to find the remaining variable you need. You need that because that fully explains what you're doing. If you don't like how long that is, that's perfectly fine. But I do it the long way because that explanation always works. I'll get back to you at 1:35. I'd like you to get those steps down. If you don't, well, you're trusting your memory. If you are a bit of a fast writer, I'll scroll it so you can see the first example. See if you can try those steps without me showing it yet. Give yourself a pat on the back if you're able to get it with those steps. Another minute. Yeah. What's the opposite of being a positive? So here, negative 2y, positive 2y. These aren't opposite in sign, they're both positive. I'll give you more time to get it. It looks like you're in the midst of that. Those mainstreamers had their test, no 100%, so their sneakers are still up. Well, no, the 2 Japanese kids got 100%, but that's a bit unfair. They're 3 years ahead of us. It's unfair. All right, let's demonstrate this. I want to solve this by elimination. What does the first step say? Ensure both equations are in general form. Are they in general form? Yes? Tick. Step 1. Choose one of the variables to look at, x or y, in both equations. Am I giving you a choice in step 2? It doesn't matter which. Which variable do you want to look at? You.
X.
Okay, let's look at x. I'm going to put a star next to this because you will learn to choose better as you practice. But we're going to look at x right now. So I'm going to put little underlines under x because our student has chosen x to look at because you had a choice. Look at the coefficient of that chosen variable in both equations. What's the coefficient of the top x? What's the coefficient of the bottom x? Good. So you've looked at those. This is the hardest step. 4. Decide on an operation to apply to all terms of one or both equations that are going to make the coefficients equal in size and opposite in sign. Are those coefficients equal in size right now? No? They're 5 and 3. Are they opposite in sign? No, they're both positive. So I need to do something to the top and the bottom equation to make them both the same number but opposite in sign. What's the lowest common number that 5 and 3 both go into? 15. So if I times the top, you tell me if you agree. If I times the top by 3, positive 3, and I times the bottom by negative 5, are the coefficients of x going to be the same size, 15, but they're going to be opposite in sign? Yes or no? Let's do it. So if I times all terms here by 3, what is it going to look like? It's going to look like this. It's going to be 15x negative 6y equals 21. Have I done any bad arithmetic there? Have I times all those terms by positive 3? I think so. I'm not trying to fool you or anything. What would the bottom look like if I times it by negative 5? All the terms. Say it. I can hear it. Say it with your chest.
Negative 15x.
Negative 15x. Yep.
Minus 10y.
Why is it minus 10y? You're right, but there's other people in this room. Why is it minus 10y?
Because positive multiplied by negative.
Yep. And then 17, I don't know that off the top of my head, 50, negative 85, is that correct? Calculator, check. You do get a calculator for this. 17 times 5, 85. Have I done an operation to both of these to make the coefficient of x, which was chosen by our student here, same size but opposite sign? Yes? That's step 4. Okay? What does adding vertically mean? Adding vertically is what you should have done at primary school. 23 plus 12. What's 3 plus 2? 5. What's 2 plus 1? 3. You can do that with algebra. Yeah? Do the horizontal line at the bottom. Say that I'm adding. What's 15x's plus negative 15x's?
0.
0. See how I eliminated x? I can't solve something with multiple variables. I can solve it when there's one. So if I eliminate x as a variable, I can solve it. If I've got negative 6y plus negative 10y, imagining your number line there, negative 6, so 0, negative 6 over here, but then I'm adding negative. So I still go even further to the negative. How much negative? Negative what?
16.
Yes, negative 6. Why is it not right? Negative 16y equals, what's 2 take 85? No, 21 take 85. 21 take 85. Negative 64. That's a nicer equation now. Did I just do step 5? Add the equations vertically to eliminate. Step 6, solve for the remaining variable. What's the remaining variable? I only have y left here. So I'm solving for that. What's the negative 16 doing to y? Multiplying. What's the opposite of multiplying by negative 16? Divide by negative 16. Divide by negative 16. Y is going to be 64 divided by is 4. Is that the end of the story? We're doing this year 10 maths now. Did I only want to find x? I've got y now. Now that I know what y is, what's the last step? 7. Substitute the variable you found in step 6 into either of the original equations. We did something like that last lesson. What did I say? Choose the easier looking one. Which is the easier looking one of the top two? They're both kind of similar. I don't like 17, so I'd probably do this one. So if I've told you that y is equal to 4, I'm going to go 5x, take 2 lots of 4, equals 7. 5x is equal to negative 8, equals 7. Opposite of taking 8, adding 8, 5x is equal to 15. X is going to be 3. I'm done now. Okay? Some moments to get that, but then I want to explain this little star that I put here next to step 2. You will learn to choose better as you practice. And actually, because this student chose to look at x, we don't need to do the second example. Okay? Because if some of you right now are looking at y, what are the coefficients of y in that equation? Are they already opposite sign and equal size? Could I have eliminated instantly? Okay? Sometimes this one, is there any instant elimination there? Right? So we would do what we just demonstrated here. Okay? You'd need to... what could I times the top and the bottom by to eliminate x in that second example? 3 and 2. Okay? But here, now that we're MLG pros, is there a better way that I can answer this? Is there already something that's the same size and opposite sign? Can I add that vertically instantly? Yeah. 5 plus 3x is 8x. Negative 2y's plus 2y's. How many y's do I have now? Nothing. Plus 0y. 7 and 17 is 24. See how y has been eliminated? Okay, 24 divided by x. 24 divided by 8. X is equal to 3. Oh, wow. It's the same. And if I substituted that x into anything, let's substitute it into the top one. 5 lots of 3, take 2y is equal to 7. 15, take 2y equals 7. Opposite of positive 15. Opposite of positive 15. Negative 15. What's 7 take 15? Yeah. Negative 2y is equal to negative 8. Y is going to be 4. Same thing. Okay? So that actually saves me because you chose to do x. We don't need to do example 2 because I showed you how to deal with example 2. Times both of them with something to match the coefficient. Or have you now seen that? Maybe think about it first. Look at the other coefficient and see if I can eliminate straight away. Okay? I'll stop the video there.